right, so we have this fencing problem. This is quad 9, number 5. So we have a fencing problem, and they have an area, and they want to break it up into 2 different fencing areas. So they maybe want to put chickens on one side and, I don't know, turkeys on the other, I don't know. And they have 1,800 feet of fencing. So that is what's given. All right. So we have to set our x equal to something, and I usually always set x equal to the width. You certainly could set it to length. It doesn't really matter, but I happen to set it to width. And I'm going to set my y equal to area. Remember, if you are writing your own problem, you need to actually define your variables. So what are x and y? So if x is my width, then I've got 3 different widths here because I'm going to have fencing here, here, and here. So if I have 1,800 feet of fencing, right now I've used 3x of it up. But I have to put fencing here and here, so I have 2 more places to put fencing. So my length will really be 900 minus 3 over 2x. So that's what my length is going to be. So now I've defined all of my perimeters with just one variable, x. So now I can write a formula for my area. Well, my area is length times width. So I can say y equals x times 900 minus 3 over 2x. So now I have one equation and one variable, so I can go ahead and graph this. So let me jump over to my graph here. And let's clear this. Let's go to our y editor. And let's type in this equation. Y equals x times 900 minus, and I'm just going to use 1.5. It's just as easy, x. And now I'm going to graph that. Let's just take a look what that graph looks like. All right, well, it's certainly not a very nice window. So let's go ahead and get some more x's and y's. So I'm actually going to start at 0, 0 since it's a word problem, and I want more x's. So let's go to 150 just so we can see what's going on. And I'm going to start at 0, and let's go up to 2,500 just arbitrarily and see what that looks like. Well, that's not much better. So let's go way bigger. Let's go 1,000 here. And let's go 5,000. All right, so now at least I can see my x's are okay. I might want to reduce them a little bit, but we still need more y's. Let's change our x's to 850, and our y's, let's go up to 10,000. And graph that. Still not enough y's. Let's change it to 25,000. Still not enough. Oops. All right, now we're starting to at least get the shape of the curve, so we're a little bit better. There we go. Now that's a nice window. All right, and now because I use this window, I'm actually going to transfer this window onto my paper. So let me just sketch it real quick before I move over. All righty. So here's my graph, and my x's was width, and my y was area, and I set my x values went from 0 to 850, and I went up to 150,000. So this is what it should look like when you transfer it to your paper, right? I don't need any lines or tick marks, just gives me a good enough idea of what you did. So now let's go back and find out what the maximum of this is. So I'm going to go second calc. I want to find the maximum. I'm going to put my cursor to the left of the vertex. Then I will put it to the right of the vertex. And I'll hit enter again. And it'll give me that x equals, I'm going to round that to 300. And y is going to be 135,000. All right, so that means that my width will be 300. So I know each one of these will be 300. And then I can just plug that 300 into this equation up here, and it'll give me my length, and then that will be my dimensions.